All right. Welcome, everybody, to episode 4 of MakerBot Chats. My name is Felipe. I'm the creative director here at MakerBot. And welcome again to my living room. It's always great to see you guys here. Just going to give a few more minutes for people to join. Today, we have a really exciting episode concerning a new material announcement that just happened yesterday, PCABS and PCABS fire retardant. Really interesting one. I actually have quite a few sample parts that I will be showing you guys, how we printed them, what's the specific applications of PCABS. I was doing an Instagram live just a second ago. There's also questions regarding the technical specifications, what's the proportion between polycarbonate and ABS. So we'll do a quick rundown of the technical specs as well. And as always, your questions are more than welcome. Do post them out in that lateral chat section. We've got Alejandra running the show behind the scenes, so thanks a lot, Alejandra, for doing that. And yeah, just a few more minutes. But, again, reminding you guys what this is all about. This is all about you. It's about the questions that you might have, generally around 3D printing, ideally anything that we can answer regarding MakerBot printers, the materials that we support, maybe best practices, how do you print something. I think at some point we also want to start touching on, if you guys want to send us certain parts, and we could be printing them just to showcase them, right? What are the parts that you are having issues or have doubts around? What's the ideal material? What's the ideal settings that you would want to use? Maybe even the different setups that we have. So yeah, it's kind of an open platform, weekly open platform. So every Wednesday at 11, we'll be having this informal conversation. And the idea is just to open it up to you guys to get informed about what we're doing, what's coming next. As I said before, today it's an exciting one because it's a new material announcement. Sometimes we'll have also new products being showcased here, which is also super exciting. We're already working on a few that are going to be coming over in the next couple of months. So yeah, do let us know in the comment section if you have any questions. And also, there's also my email right there, so Felipe@MakerBot. Or if you just want to sign up to learn more about these specific sessions, just go to makerbot.com/chats, and yeah, we'll get in touch. So I think that's enough time for everybody to join. Welcome again. Thanks for coming in. Today in MakerBot Chats, we have a brand new material. It's called PCABS. I always almost a quarter of a spool out here, so I've been printing quite a bit with it. Right now, it only comes in black. The sticker is just temporary, but it's the same, the same material that material format that we have been using for Method. This material is only available for Method X. The reason being that it needs quite a high temperature in the build chamber to actually print correctly. The chamber goes all the way to 85 C. And that's not only, it's important to know that even if you have a heated build plate, if you don't have a heated chamber, it's going to be hard to print with some of these higher temperature materials because of the fact that they will start peeling up even after. So with a heated build plate, once you get a certain distance away from the heated build plate, you start losing that benefit of the heated build plate. And with the chamber, what happens is that you're actually controlling the whole print environment, right? So I'm not only focusing the temperature here, but I'm able to print with a consistent temperature in every single layer, not just the first couple of them. So for PCABS, the print settings are as follows, right? You will need to have 85 degrees in the print chamber, so hence you need the Method X to print that. And it's going to use SR30 as support. So here I have another part. It's actually a card, door handle. This was printed horizontally like that. And as you can see, both the raft and the supports. So the supports are, as you guys know, the structure that's created to support, hence the name, the actual print structure, right? So PCABS will both we have PCABS and PCABS FR. We'll have that. Let me jump here into a new slide. But we'll have both will use SR30 as supports, right? So it's going to be available right now only in black. But it's a really interesting material, right? We've heard that it's being used a lot for automotive industries. That's why some of the sample parts that we have, let me move to the side a little bit. Some of the sample parts that we have are basically that, right? In this case, the car handle. I also have right here a halfway printed train car holder. So in Europe, they use this a lot as replacement parts. So directly to replace, instead of having a small batch of these, like the hand holders that you get and grabbing to the subway, not so much nowadays, but when you're trying to replace some of those components in the transportation industry, it's really hard. It can be really expensive to submit an order. So if you want to, let's say that you're trying to replace 5 or 10, it's just better to print a few as opposed to having to put an order for 100 or 1,000 pieces. So that's where something like this really comes in handy, right? Where you can actually just print something quickly, replace that part out, and have another one, which is the one that's featured right there on that image. It's these air conditioning vents, so very similar to what you would see. Oh, sorry, here we go. What you would see on an airplane. This is just kind of the model, the prototype, not necessarily the functioning one. But you can see the idea, right? So you can print both the cover itself and the little nozzles. And the print quality is really smooth, right? It prints very similar to ABS. I think, it's, of course, it's got a lot of ABS in it. We'll touch on the print settings in a second, sorry, the technical specifications in a second. But I think that the consistency is really similar to ABS. It definitely feels stronger and stiffer. I would say the print lines are really smooth, really nice. You can see it here. So this part is an interesting one because no matter how you orient it, you're going to require supports. And I'll talk about this one in a second. But actually, you can see how all of the geometry was very smoothly printed. You can see even in the how it shines and reflects. The layer lines depend a lot on the part orientation, right? Depending on whether I print it like this or like that. And that'll also affect the support generation. But let's get into the specific, let me switch here, specific technical specifications. And again, if you have questions as I go through these, please post them in that comment section in YouTube and let us know if you would like to know anything specific about the material. But so PCABS and PCABS-FR. So FR stands for fire retardant. It's actually, that's one of the reasons why it's widely used. And let me move. Can I move? No, I cannot move it. It's widely used in the automotive industry and also in many train and railroad applications because of the compliance that they need. When they are substituting any one of these components, they need to make sure that if anything happens to them, right, they will withstand a certain temperature, or worst case scenario, they will not emit particularly harsh fumes if they are ignited. So overall, the subtending temperature starts at 100 degrees C. That's pretty hot. That's one of the reasons also why you need to have the chamber printing so high up, the chamber temperature itself. So as I said before, you need to print it at 85 C, which is pretty darn hot. It's almost boiling temperature, right? It's pretty strong. I think it's fairly comparable to ABS. And specifically regarding the applications, we've seen it a lot used as for functional prototypes. We know other manufacturers that actually supply these. Also as end-use parts, kind of what I was showcasing here with the train handle, where you are definitely going to swap one-to-one the part that's effective or the part that broke down. Let's say that you have this handle in a subway system or a subway car, and then you just print a new one because the old one broke down, wore off, or whatever. It's also one of the versions is flame retardant, which it's just to say that it'll both prevent the spread of fire and comply with certain guidances that we have, depending on where you live, that might change. So we can look at that in detail in a second. And it's also able to print fairly complex geometry, specifically using SR30. I'll get to that in a second. But I was talking about these specific parts. So the part on the right, this handle, no matter how you print it, you will need supports, right? And some of these more advanced materials won't print with any other support. So you might end up needing to use breakaway supports if you don't have a dual filament system. With Method, you're able to use SR30, which is great because it's, once it's done, that white outline, I don't know if you can see it here. Yeah, you can see my mouse. So this white outline is going to basically get dissolved, which is what happened in this part, after the printing process is done, right? So you're able to print the part in any orientation, depending on whether you're optimizing for a specific strength or a specific layer alignment, have the supports be generated, and after the fact, just remove the supports and get your finished part without any hassle, really. So here we have both tech specs for PCABS and PCABS-FR. As you can see, they are fairly similar. PCABS is a little bit stronger in some regards. Specifically, tensile strength is going to be 5,300 psi versus 8,700 psi for PCFR. So it's close to 35-40% more. than what PCABS is, then well, you can actually read through them. That this is actually also already live in our site. So if you go to makerbot.com/materials, you can navigate to the PCABS and PCABS page and download this exact product brochure, right, which will take you through all of the technical aspects of this part. Now, the thing that I want to focus and spend more time on is actually talking about some of the implications of printing with it, right? Specifically, now that I've been showing this part, I want to show you guys how I developed this part and then how I printed it, which orientation I chose and why. So if I jump here, I think that this is going to be the first time. Let me find. Here we go. My Rhino window. I love Rhino. Some people call me old school because of that. I generally use either Rhino or SolidWorks. I'm also well versed in other Autodesk features and materials. But for this one, I chose to use Rhino, and specifically, let me expand this. So this is how I generated this specific train card holder, right? It's a very smooth surface, so let me just focus in here. Everything is rounded off, which means that no matter how you orient this part, it's always going to require supports, right? You can either orient it vertically, you can orient it horizontally, which is the way that I've been printing it so far. And the thing that is going to change with your part orientation, it's mainly the, the layer lines, and in some geometries, it can affect the performance of the part, right? We'll talk about that in future episodes, but just like how does layer lines correlate with part strength? Layer lines will just, the nature of 3D printing creates not, I think it's called not anisotropic materials, which means they don't necessarily have the same strength in every single axis. It's way stronger when you have the heated chamber, right? Because it actually allows for that change in strength on the vertical axis to dissipate because you're constantly heating up the material, but it will definitely change the way that the material performs depending on the part orientation. So let's say that you're done with this part, right? You've already finished smoothing it out. You see how it's already looking pretty legit, pretty straightforward of a part. Then the next step would be to actually export and bring it over to MakerBot Print. So we have many plugins are available for you guys to use, whether you're using SolidWorks, you're using Autodesk Fusion 360, that will directly send the part over to MakerBot Print. And once you have it in MakerBot Print, you can go ahead and do a similar exercise to what we just did in Method, right? So it's a very straightforward process. In this case, what's happening now, and let me change this for a second. So I'm going to select a different printer because the one that I'm currently using here, it's busy. But I've got a different method X, right? And what the first thing that you will notice is that there's a little square floating around the part itself. That square is what we call the perch tower. The perch tower is the material that's going to be deposited as an extra element for the part in order for the nozzles to clean themselves up, right? So when you're printing with two different materials, you need to swap between nozzle 1 and nozzle 2 constantly. In order to avoid any sort of stringing, any sort of defects with the part, the machine itself is going to print a little tower close to that part in order to clean itself. It's kind of like a purging area, that it'll visit every time that it toggles between nozzles in order to avoid any sort of contamination between the two materials. So that part, that little square represents that perch tower. You can move it around and orient it any way you want. And as I was saying, the part, it's also something that you can change and orient in any way you want, right? It could be a vertical orientation. It could be a horizontal orientation like what we have. It's also easy, here I can go and arrange build plate and it'll automatically, fit the part to the build plate and make sure that it actually is aligned to the best orientation that I might want to use. And then you can either directly export the part if you're ready. Also visit the settings. Right now I have only ABS and SR30 here. So you just change the material here to be PCABS, and in this case, that will require SR30 support, so there's nothing to do there. Change the print mode, maybe select whether you want to raft or not. the different temperature settings, which as I said before, as soon as you select PCABS, this will default to 85C, and you can directly export that file, or the better way to do it, I would say, is to get a preview. Why would you want to get a preview? Because that can actually change or challenge a little bit your part orientation. So what MakerBot Print is doing right now is actually generating the whole tool pathing document, so the slices, right, that this file is going to be split into, in order for me to know how is this part going to look, how are the supports going to be generated. I'll let it finish for a second, and in the meantime, I'll show you guys just this part, already printed out. So I stopped the part halfway through, just to show you guys what's the infill settings that we're using. In this case, it's 20% infill with this linear lattice, very straightforward. Um, and the part, as I was mentioning, was printed this way. So once I finished printing, I actually just removed the supports down here, because as you can see, there's really no flat edge in the part, right? Because of this little bulge here, like this rounded element, it's impossible for the part to sit flat against the surface. So because of that, I forced myself into having to use supports, right? Which is good and bad, right? In a way, you could design your way out of it. You could design a part that doesn't require supports. For example, I have this other part. This is also polycarbonate. It's not ABS. It's just regular polycarbonate from Polymaker. The material is called Polymax. But this part is just a little bracket that I printed out to hang stuff around in the house. So this goes against the door, and I can hang stuff. But anyways, by designing a flat extruded part, even though it has these rounded elements, even though it has like multiple geometries associated to it, I can print it without supports. And the reason why would you do that? Well, it's basically you can save time, you can save a little bit of post-processing time, but with the soluble supports, you don't necessarily have to compromise on that, right? You can just print it with supports, and it's going back to this support generation animation. It's what's happening right now, right? So what you see happening here is MakerBot Print is detecting the areas that will need support. Those are highlighted in yellow or that orange color. And the green parts are the actual parts that will have the regular material. So in this case, the PCABS material that we will be printing with. Let's see if it finishes, but you can see how it slowly generates every single layer, and also gives you a preview of what's going to happen. You can see what I was talking about before here in the lower left, where it's generating that perch tower, right? And the perch tower, as you can see, has also two colors, so it's done. It's a 10-hour part, not too bad, 10 hour and a half. Now you can also change the orientation of the location of the perch tower, and that might affect the print time. Why? Because the nozzles will have to travel every single time to that perch tower in order to clean themselves up, right? So if you put it in a more center space, meaning which is the way that I actually originally printed it out, if you put the tower here in the center, you're going to be able to just simplify it a lot for the machine, because then it doesn't need to travel all the way to the outermost corner to clean itself up and then return to the material, to the model, right? And here it's, I just really like this toggle view where I can see like layer by layer what's the actual process going to look like, if there are any issues with my part. Sometimes you sort of have either issues with the mesh, or maybe you're seeing supports in an area that you didn't expect support. So this preview actually is a great way for you to look into that, have a first idea of how the part is going to be printed out. And just for fun, while we talk about some other parts, I will change the orientation of this part, and I will make it vertical. So just keep in mind, right? For the flat orientation, this part was going to take 10 hours to print. Let's compare that, and let me arrange that build plate, and let's compare that with how much time will it take for me to print it vertically, right? Again, you can do it either way. You have both options, so I'll let it run for a few minutes. But what we should expect is that now, let me fade back here. Now that I'm trying to print the part vertically, it's actually going to generate supports in all of this area, right? So most of this triangle is going to be filled up with supports. This is not ideal. I mean, it all depends on what are you trying to do, and you could always say, well, would you want to print it this way or that way? Strength-wise, it's going to be a similar result, but the differences in supports are going to be quite noticeable because if I printed it this way, you can imagine how I will need to generate supports all the way through on the outside and also all the way through on the inside because I have this large overhang here, right? So MakerBot Print is right now just estimating the print time and the support needed and the material needed for this specific orientation. Again, comparatively, I would like if I had to bet, this is going to be probably around 18 hours, I would say. But let's see. So flat, 10 hours, vertical. We'll come back to it in a second. In the meantime, let's talk a little bit more about some other parts that I have here. So in this case, where did I leave that here? It's right here. Another polycarbonate part that I printed before. We talked about this one last session, and it's a really interesting one because of the same, need for strength that you have. This part, the same idea applies, right? Why would you print it vertically versus flat? If you print it flat, you require almost no support, unless you have to print it with this hollow area facing down. But again, I think that the big takeaway is that you have to consider as you're preparing your files to be printed out, two things. I think the rule of thumb. What's the strength requirement? What's going to be the best orientation for your part to give you the best strength? And second one, the time, right? Which orientation will generate more or less supports. And that's going to change quite a bit depending on the part, depending on your expectations and whether or not you have changes, or specific requirements in how the part is going to perform, to behave. So if I go back to this other polycarbonate part, so this fan, let me just fade back to just my webcam here. So if I printed this part, let me, where, here we go. If I printed this part horizontal like that, so facing sideways, two things would happen. First of all, I would get a lot of support generated as opposed to what happened when I printed it this way. When I printed it this way, it just generated support in the first couple of layers, basically just this section. And that was it, right? The whole top part sort of self-stands on itself. If I print it sideways, it's going to generate supports in all of this, will require supports. Most of the fence, if you see like face on, will require supports throughout. And not only that, but it'll also create layer lines in this direction, which is parallel to the strength, perpendicular to the strengths that are going to be applied to this part. So you can imagine as this fan is blowing, the strength that is resisting the movement, right? The air resisting the movement is going to push back on each of these pins. If I place the layer lines aligned with that strength, it's actually going to compromise my part and it can have a negative effect on the performance of it, right? Ultimately, it can make it fail. So it's just something to keep in mind. Part orientation, very important for two reasons: material usage and part strength. Going back to, let's just see how MakerBot Print is doing. You can see how it's slowly starting to generate the support structure. And again, we are printing this train holder vertically, just trying to compare how does this, is it a lot longer than regular horizontal orientation, or is it going to be a little bit faster? I don't think so. It's going to require quite a bit more supports. You can already see how it's generating supports. Let me put this here in all of the internal area because all of this triangle now needs to be supported, right? It cannot just print in thin air. With 3D printing, you always need to have some sort of material to print up against. So as you're sort of creating these new layers, you need the scaffolding to support those new layers. But yeah, let me know so far if you have. I can see already some of the questions coming in. Is it risky to print so close to the edges of the build volume? Not really. Actually, there's already a buffer zoning method that encompasses for that, right? It's actually really straightforward, but the printer will never damage itself. The parts itself will not be affected if you get too close to the edges of the build volume. The whole idea is that with a heated chamber, and that's one other thing that you have to keep in mind if you're not using a heated chamber system. With a heated chamber, all of the build volume is controlled, not just certain parts. And we see it happening a lot with just heated build plates or sometimes with just regular build plates, right? With the Rep Plus, if you start printing too close to the edges, you can start to see some curling happening in the print. With Method, that's just not the case because the whole volume is going to be controlled, and the printer is meant to actually reach out all the way to the edges and basically print successfully every single time. Can I print without supports and use only material only? Oh, you're getting a new method. Congrats. That's super exciting. You should see episode, I think it was episode 2, when we did the unboxing of this guy. It's super straightforward process. I'm sure if I were you, I would just document it because it's kind of a fun one. Um, yes, you can print without support. Well, okay, you cannot print without supports, but you can print with a single material. And what I mean by that is that it's possible for MakerBot Print to generate supports out of the same material uh, that you're using for your model material. We call them breakaway supports. So instead of having to dissolve them afterwards, you would need to peel them off with a plier or a little spatula in order to get rid of them. I'm not sure if I have any good examples. Oh, no. I don't currently have any examples of breakaway supports right here. But the answer is yes. You can print with a single material, not without supports, because without supports, well, the part is just going to fall off. But you can print with breakaway support. So you just go to MakerBot Print, select breakaway supports, and there's that, right? So you're printing with a single material. I have another interesting print. This one is ABS. I want to, maybe at some point just do one chat for funsies, kind of these weird structures. I like to play with Grasshopper a lot. I don't know if you guys are familiar with it in Rhino. And it's kind of interesting because it's a great way to push the limits of 3D printing, right? You are able to generate these very complex surfaces. In this case, it was just a random project that I had, just messing around with the printer, and I wanted to see how hard would it be to print very complex parts with a method. And you can see how delicate, both delicate this part is, and how clean it came out. I was using this is ABS, and it's using SR30 as supports. And after the resorts are gone, the part is just, you know, gorgeous to look at it. There's no real specific application for this one. Just an interesting thought experiment, but, I thought I would bring it up. Let's go back to MakerBot Print. I think the visualization is now over. So yeah, 21 hours, you can see it here. So once the print preview is done, a few things are happening here, right? You're being displayed the material that the model material, which is this green one. Extruder 2 represents the support material, and then you can have a layer highlight just to know how high up in the model you're at. You can also select here all layers. I want to see all layers at once. Let's toggle to that. Here we go. And you can see, immediately see why there's such an extended print time happening here. Not only are the supports required throughout the part, so all of the internal, structure of the model now requires supports, but also the perch tower, and that's one thing that you have to consider, right? The perch tower is going to go as high, not as high as your model, but as high as the last layer of support material that you have, right? It's going to accompany that support generation, so to keep constantly cleaning the nozzles. And the importance of that is, well, you really want the nozzles to not contaminate each other because you don't want soluble supports inside of your part, which is why the toggling happens, right? It goes out, it cleans itself. You can disable this feature, of course. I've done it, and it's not super risky, but again, if you're trying to do something, you know, legit and serious, I would say like just keep it there. It's just going to give you so much peace of mind just having the nozzles cleaned every time, and it creates parts that are just plain and simple, clean, solid, sturdy, and they work. So 21 hours versus the 10 hours 30, it's quite a change, right? Quite a dramatic change, and you can see the reasons why. The part orientation is going to affect not only the material use, you're also using more material. So this is 80 grams of SR30, I think, and the other one it was like 20 grams. I'm not sure, but it's way less than that, right? So another thing to consider when you're exporting your file, when you're preparing your file, it's precisely that. Part orientation will affect mainly two things: strength, part strength, and material usage. Whether that be just because of the material for support or also the model material can change, the way that it actually behaves. And with that, I'll start closing things up. If you guys have any more questions, do let me know. It's always great to hearing from you guys. We are now doing this set up in both Instagram Live and in YouTube Live. It's always nice, to know what are the questions from the community, what are the things that you guys are struggling with. To summarize, I'm doing a quick recap. So today, PCABS, new material, well, two new materials, right? Technically, it's PCABS and PCABS FR. It's kind of like a really interesting application, very similar functionality, performance, I would say, than ABS. PCABS FR has a way higher heat resistance and also impact strength. You can check that. We checked the technical specs of it. And we talked a little bit about part orientation, right? What are the implications for both part strength and material usage, which are really important elements to consider. Once more, as we said last time, there's a really nice promo, and I know that somebody already got their new method just this week. There's a really nice promo running right now, which is kind of crazy. It gives you, access to the method for 3,500 just about. It's crazy. It's a solid machine, and at that price point, I think it's just hard to compete with anything else. It's just amazing for me. I'm naturally biased, but yeah, I would just say check it out. And if not, then it's great seeing you guys. Thank you guys all for joining today. Do make sure to send us any questions that you have, either to hello@makerbot.com or Felipe@makerbot.com. That's FELIPE at makerbot.com, or also through social media. Give us a follow. It really does help us to know, what you guys would like to know more about in the future. What are the things that you would like to discuss in the next episodes of chats? Because ultimately, this is all about the questions that you guys might have, right? What can we do to make your guys' lives better? What are the things that are bugging you about either method, replicator, sketch, any sort of, that's another thing to point out, right? This is not limited to the method series. So, and, for MakerBot for the matter, right? If you have general 3D printing questions, I'm more than happy to discuss them. And yeah, I could say that I like 3D printing. So give us a follow out in in Instagram and Twitter. Or otherwise, let's just join for next time. And it's always nice seeing you guys. Let us know if you have any more questions, and we'll see you next time. Thank you.